If you've been around here for a while, then you know that I just bought a new house and that I'm on a journey to make it the best dang smart home that ever was. So far, I've managed to get my internet access, home network, and a server up and running in my comms cabinet, which is a great foundation to build on top of. Next up, I need to install some smart devices like light switches and sensors and start creating automations. But there are so many devices out there on the market that it can be really easy to accidentally buy the wrong one. I need to be sure that any device that I buy will be able to talk to my smart home platform and to work in my automations. I also don't want to end up in a situation where I have to have 5 hubs connected to my network so that I can control all my stuff. If you look online, you'll see that you can buy many different motion sensors that all look pretty similar. What's the difference between them all? Smart home devices, for the most part, connect wirelessly to your smart home system. In this case, wireless doesn't have to mean Wi-Fi, like your phone uses to connect to the internet. It just means without wires. Smart devices use different languages to talk to each other wirelessly. Here's a motion sensor that uses something called Z-Wave. Here's another one that uses Zigbee, and even one that uses actual Wi-Fi. What I need to do first is choose what languages I want my smart devices to talk, and then make sure that I buy products that are able to speak those languages or are compatible with each other. In the tech world, these languages are known as protocols, and these protocols are used in a network. So for a smart device to be able to talk to your home automation hub or any other smart devices, they need to use a protocol that your smart home understands and be connected to the same network. It's just like how your computer and your printer need to be connected to the same Wi-Fi network before you can print something out. So in this video, I'm going to take you on a quick whirlwind tour of the main smart home protocols that are out there, tell you what I like about them, what I don't like about them, and why I've chosen Zigbee to be the main protocol that I'm going to be using in my new smart home, at least for now. Let's take a look. We'll start with Bluetooth, because it's a protocol that you're probably already familiar with, and you probably use it to connect your headphones to your phone or a mouse and keyboard to your laptop. There are some home automation devices out there that can be controlled via Bluetooth, like some of the Philips Hue lighting products. These are a great place for people to get started with home automation, because pretty much every mobile phone these days has Bluetooth built into it. You can simply buy a smart Bluetooth light bulb, connect it to your phone, and then change the colors or the brightness directly from the Philips Hue app without buying anything else. If you want to grow your smart home a little bit, you can then pair these Hue lights directly with a compatible Amazon Echo device and turn them on and off or adjust the brightness using your voice. Bluetooth works fully locally in your house, which means that you can still turn on and off the lights when you have no internet connection, and in some cases, companies won't make you sign up for one of their cloud accounts just to use their products, which is what we ultimately are looking for when we're choosing smart home devices. Bluetooth smart devices usually use something called Bluetooth Low Energy, which, as the name suggests, uses very little battery power. Unfortunately, you can't really do a lot else with this Alexa-enabled smart light, and it only really works in the same room as you because Bluetooth doesn't have a huge amount of range. There also aren't a ton of Bluetooth smart devices out there, so you're limited in buying a handful of things, and it's a relatively slow protocol, so you might have to wait a second or two for your devices to connect to your phone before you can use them. For me, Bluetooth really doesn't bring a lot of value to the smart home party, so I'm going to try and avoid buying Bluetooth-based smart devices for now. I would probably use it if there was some device that solved a problem that I had and it only worked with Bluetooth, like these plant and soil testing sensors, but sorting out my garden is a project that I'm going to take on in the summer, so we'll take a deeper look at them later in the year. Next up, we'll look at Wi-Fi. I think that this is a pretty good home automation protocol because most people these days already have Wi-Fi, so you don't need to get any extra infrastructure. Wi-Fi is also the best protocol for smart devices that need a lot of bandwidth, like security cameras and anything else that involves video. But sadly, a lot of internet service providers give their customers some pretty cheap and underpowered Wi-Fi routers to go along with their internet connection. Some of these routers only support a dozen or so wireless devices connected at any time, so they can quickly become overwhelmed once you start adding a bunch of smart light bulbs, switches, and sensors alongside your TVs, mobile phones, and laptops. A lot of companies that make Wi-Fi based smart home devices also do it so that they can force you to sign up to one of their cloud services before the device will even work. A great example of this is TP-Link, who used to make great locally controlled Wi-Fi smart plugs. Then they discontinued these and replaced them with a new version that will only work if the plug is able to talk to the internet. So when you use your phone to turn on this wireless smart switch, it sends the signal from your phone inside your house up into some server in who knows what country, which then sends the signal back down into your own house to turn the switch on. Why? Not only does this invade your privacy because some random company now has a log of every time you turn on and off your switch, but it also makes it noticeably slow to react. Wi-Fi is also quite a busy and noisy protocol in some houses. If you're hogging all the Wi-Fi bandwidth watching 4K Netflix shows, then the signals to turn on and off the lights might get stuck in the queue, slowing the whole thing down even more. And because your devices are connected to your Wi-Fi network, which is connected to the internet, it also makes them more susceptible to getting hacked or taken over. I happen to have a really good Wi-Fi network here in my house that can support hundreds of simultaneous devices, so I'll definitely be using some Wi-Fi devices in my smart home. These will be things like Chromecasts for streaming video, maybe some security cameras, and my robot vacuum cleaners. I might even use some Wi-Fi based smart wall switches if they happen to look sexy, work locally, and have all the features that I'm looking for. But that's the topic of the next video. But generally, I'm going to try and avoid Wi-Fi based smart devices if I can. Next on our list, we have Z-Wave, or Z-Wave if you live in some parts of the world. Z-Wave is a protocol that was designed specifically for smart home environments, unlike Bluetooth and Wi-Fi, which were originally created for different reasons and have been adopted by the smart home industry. Z-Wave is an awesome smart home protocol, and I have mostly only good things to say about it. One of the best things about Z-Wave is that it creates something called a mesh network. A mesh network is a computer network that gets stronger and more reliable as you add more devices to it. That's because Z-Wave devices that are hardwired into electrical power can act as a router, which other Z-Wave devices can then connect to. This lets Z-Wave messages bounce from device to device until it eventually gets to the hub or controller. Each router you add extends the range and reliability of the overall Z-Wave network. If you're in a situation like me and you have your home automation equipment in the basement, then you can add Z-Wave devices like light switches into your other rooms of your house, and they will amplify the network into the farthest corners of those rooms. Z-Wave is also a low power network, so any battery powered sensors and devices that you have will use very little energy. It's not uncommon to have your battery sensors to last for over a year or so on a single battery. Along with being a low power network, Z-Wave is also a low frequency network, working at around the 900 MHz radio spectrum, which not many other radio devices use anymore. This makes the Z-Wave network less susceptible to radio interference, and the lower wavelength makes the signal great at going through walls and floors. And the icing on the cake for Z-Wave is that it's a fully local network, so the devices are not accessible from the internet or your Wi-Fi, and the messages sent between the devices are encrypted. These things make them more secure than other networks and ensure they keep working even if your internet connection goes down. On the flip side, the lower power Z-Wave network also has very limited bandwidth available, about 100 kilobits per second, which is significantly slower than Wi-Fi and even slower than Bluetooth. This makes Z-Wave a terrible choice for bandwidth intensive purposes like streaming video, security cameras, or streaming audio. But it's really not a problem for sensors like motion sensors, light switches, or temperature sensors because they send very little data. Just on, off, turn blue, how cold is it? And sadly, one of Z-Wave's greatest strengths is also one of its biggest weaknesses, and that is the Z-Wave Alliance. For a product to be allowed to have the Z-Wave logo stamped on it, it needs to be certified by the gods of Z-Wave. And you can only ask for a Z-Wave product to be certified if you yourself are a member of the Z-Wave Alliance. The great thing about this is that you can be guaranteed that a certified Z-Wave product will work with every other single certified Z-Wave product. That's what the certification is designed to uphold. Unfortunately though, getting a product certified is quite expensive, which might be prohibitive to some smaller companies. And companies that can afford the certification fee will no doubt pass that cost on to consumers, which is why we typically see Z-Wave devices cost a little bit more than their Bluetooth, Wi-Fi, or Zigbee equivalents. Also, unlike Bluetooth and Wi-Fi, you won't find Z-Wave built into your smart home or laptop, and you'll need to buy a separate Z-Wave hub or controller for these devices to connect to. But overall, it's an amazing smart home protocol, and the positives of it far outweigh any negatives. If you've got a bunch of Z-Wave devices already in your network and you're happy with them, then there's no reason to move away from it. Keep using Z-Wave, it's awesome. But I don't personally use Z-Wave, I use Zigbee. And why do I use Zigbee? Well, the first smart home product that I ever bought way back in 2016 was a Philips Hue starter pack that came with a couple of light bulbs and a Hue hub. When I eventually outgrew my Hue hub, I looked for alternatives that would let me reuse the light bulbs that I already had. It turns out that Philips Hue uses Zigbee, and staying with that protocol let me keep reusing these bulbs. Zigbee has many similarities to Z-Wave. Firstly, it also creates a mesh network, so almost every single hardwired device that I add to my Zigbee network makes the overall system stronger and more resilient. Just like Z-Wave, Zigbee creates a local network separate from your internet connection and Wi-Fi network. The data sent between devices is encrypted, and it uses very little power. I've had Zigbee sensors running on a single CR2032 battery which have lasted for more than a year. But whilst the Z-Wave network runs on a relatively quiet 900 MHz radio spectrum, Zigbee runs, unfortunately, on the 2.4 GHz spectrum. This is the same area of radio waves that Bluetooth and Wi-Fi run on, which makes it a little crowded. It's possible that your Wi-Fi networks and Zigbee networks could clash with each other and cause performance issues. But there are ways to prevent that problem, which I've covered in a previous set of videos all about Zigbee, and I've linked to those in the description below. Despite using the same radio spectrum as Bluetooth and Wi-Fi, it's still a low bandwidth protocol with a max throughput of about 250 kilobits per second. This is 2.5 times faster than Z-Wave, but still way too slow for video, audio, or anything like that. And just like Z-Wave, Zigbee also has an alliance and a certification program. But the Zigbee certification system seems to be a little more lax than the Z-Wave one. I'm not an expert on how this works, but I've heard that some vendors implement Zigbee in a slightly different way to others, which means that they don't always work the same from one hub or software to another. And the final reason that I use Zigbee is because of the sheer number of devices that are available. When I was looking for smart light switches, I could only find a handful that were Z-Wave compatible, compared to the hundreds that I found that were working with Zigbee or Wi-Fi. The amount of Zigbee products that you can find on Amazon or AliExpress is mind-blowing. There's even a Zigbee pet food dispenser. I've never seen a Z-Wave version of that. So to recap, the reasons I am once again choosing Zigbee to be my smart home protocol of choice is because it's a low-power, local, and encrypted smart home mesh protocol that supports a huge variety of devices. I also have a bunch of Zigbee devices from my last smart home that are perfectly good, so why would I change now? I'm hopefully going to install Zigbee-based smart wall switches into various rooms of my house, so they should create a really solid mesh network that will mitigate any of the interference or range problems that might occur with it being on the 2.4 GHz network. I'll just need to be especially careful about what channels I'm running my Zigbee network on and how that overlaps with the channels that I'm running my Wi-Fi network on. I talk about that in more detail in that video I mentioned earlier, so you should go check that out if you want to create a rock-solid Zigbee network. A lot of people watching are probably shouting at their screens right now, saying, "What about Thread? It's the newest and shiniest smart home protocol around. Surely you should use that. What about Matter?" Well, let me talk about that real quick, because it's a fair question. Thread is a newer smart home protocol that, to me, looks a lot like a new and improved upgrade to Zigbee. In fact, it's based on top of the same radio hardware that Zigbee uses, so it also uses the 2.4 GHz radio spectrum and has the same 250 kilobits per second throughput. And just like Zigbee, Thread creates a low-power, encrypted mesh network that's been designed for smart homes. It even has a similar certification program to Z-Wave and Zigbee, so you should be able to confidently purchase Thread-certified devices that work together. It all sounds very familiar at this point. So what makes it new and improved? Firstly, one of the downsides with both Z-Wave and Zigbee is that you can only ever have one hub, controller, coordinator, whatever you want to call it, active in each network at a time. If your hub breaks, gets turned off, or is otherwise inaccessible, then the entire network goes down. If this hub is actually broken and you need to replace it with a new one, then you need to go around and reconnect all of your devices all over again, unless you're lucky enough to have some sort of backup of your network that you can restore in some way. One of the major benefits of Thread is that you can have more than one hub in your network, known as routers. One of these routers is elected to be the leader, and it becomes the boss of the network. If this leader hub gets turned off or breaks, then another router in your network can take over, making the whole network more resilient and less likely to fall over. Another benefit is that Thread devices have the ability to turn off their radios when they're not needed, making them even more power efficient than Zigbee and Z-Wave devices. Where a Zigbee device might last a year on a battery, an equivalent Thread device might last 2 or 3 years. And finally, Thread uses IPv6 addressing, so it should be able to talk to Wi-Fi smart devices and other services on your home network or even the internet. I'm not sure how that affects security, but it could open up some pretty interesting use cases. So if Thread is so awesome and so similar to Zigbee, then why am I not upgrading to it? Thread is relatively new, so while we're seeing more and more smart home manufacturers adopt Thread, it still has its teething problems on some platforms. There are also way fewer devices available on the market at the moment. Zigbee has been around since the 90s, so it's got a long history of being a solid home automation protocol, and there are so many devices available for it. Eventually though, vendors will stop making Zigbee devices and focus exclusively on Thread, and my smart home is going to be ready for it. I use Home Assistant for my smart home brains, and a USB SkyConnect Zigbee dongle. This dongle lets me connect my Zigbee devices directly into my Home Assistant, as you may have seen in my previous videos. The good thing about the SkyConnect is that it will support Thread in a future free software update, so I'll be able to run Zigbee and Thread devices in parallel in my smart home, both talking to Home Assistant. If one of my Zigbee devices stops working and I need to replace it with a new one, then I'll certainly be looking around to see if there's a Thread-compatible device that I can use to replace it. There's just currently no reason to throw away my perfectly good Zigbee stuff just because a shiny new replacement protocol is available. Over time, as Thread becomes more mature and more adopted, and I start buying new smart home devices, I'll eventually phase out Zigbee and replace it with Thread. My next job is to decide what smart light switches I'm going to be using in my house. I took a look around to see if I could find any Thread switches, and I could only find one that was suitable for the UK, and that's this one made by Eve. £100 for a light switch? I can buy 3 or 4 Zigbee or Wi-Fi light switches for that price, and they'll turn on and off the lights just as well as this one. So what about Matter? Well, Matter isn't actually a protocol at all, it's a standard. It's been designed as a way for smart home devices that speak different protocols and are from different manufacturers to talk to each other. So Philips Hue, for example, are adding Matter support to their hubs. This means that a Zigbee-based Hue light bulb will be able to communicate through the Hue hub to another device that supports Matter. So if you buy Matter devices, they will still need to wirelessly communicate using one of the protocols that we discussed in this video. You should now hopefully have a better understanding of the different smart home protocols that are out there, and why I've chosen Zigbee to be the one that I'm going to use most in my house. In the next video, I'll be testing out a bunch of different Wi-Fi and Zigbee-based smart light switches to see if I can find one that is the perfect balance of looks, functionality, and price, so that I can finally start smartening up this house. I didn't want to launch straight into the comparison video without first explaining the different technologies available to connect them up. If you want to see what switches I ended up with and why I chose them, then make sure you're subscribed to the channel so that together we can make your home smarter.